Hello everyone, welcome to OneClass. My name is Shanjida. I am currently a second year human biology student at the University of Toronto. And so today I'll be going over some commonly asked chemistry questions, both at the university and high school levels. And also, if anyone needs any additional schoolwork help or needs tutoring, you can check out the description box below. And other than that, let's get started. Okay, so over here we have our first question, which says, what is the charge of the nitrate ion? Okay, so the formula for nitrite ion is basically NO2 negative. Okay, and so to basically calculate the formal charge, right? To get the formal charge, we must address the difference between the number of valence electrons and the electrons actually assigned to that atom. So if you recall, right, so nitrite has 2 oxygens and 1 nitrogen. So this is a covalent bond, right? And so basically, so when you're talking about like polar covalence or non-polar covalence, you're actually talking about electronegativity. And so if you recall that oxygen is more electronegative than nitrogen, right? If you want to see here, you can see that oxygen has an electronegativity of 3.5 and nitrogen has an electronegativity of 3. Okay, and so if we go back here, so therefore when we draw the structure of nitrate, the negative charge is much more likely to be on the oxygen atom. So also, if we want to draw out the structure here, which we can, so I'll just use this color. Okay, and so I'll draw all the possible structures we can make for the nitrite ion. Okay, and so number 1, we can have so our central atom would be nitrogen. We have oxygen here, right? And nitrogen has 2 more valence electrons, and so this is gonna be just a neutral. Basically, this is gonna be one of these structures, and so oxygen has 3 lone pairs. Okay, both the oxygens here will have 3 lone pairs. Okay, and so if you want to calculate the formal charge here, you have +1, right? And you have -1, and you have -1, right? Because oxygen can form 2 bonds, and I only created 1. Okay, so let's just say this is number 1. This is one structure. The other structure it can have is nitrogen can double bond with the oxygen. Okay, and so that makes nitrogen having no pairs of electrons or lone pairs, and each oxygen has 2 lone pairs. Okay, so the charges of both the oxygen would be 0, and nitrogen would still be +1. Okay, because it's basically it already fulfilled its octet basically. Okay, and so our third option would be we have here nitrogen. It could single bond with one. So which one would be most likely? Okay. And so here's oxygen, single bond, and then we have a double bonded O here. And this would have 2 pairs of lone electrons. And so your nitrogen would also have another pair. Let me drop this. Okay. And so the charge on your on this oxygen would be -1, this would be 0, and this would also be 0. Okay. And so as you can see about all these 3 structures, the most likely of them to exist would be C, is because it has a negative charge on the electronegative oxygen atom. Okay. Whereas nitrogen is 0, and the other oxygen is also 0. Okay, and so so basically the simplest formal charge distribution would be on the third structure here, on the oxygen on the right. And so we can basically say we can add the formal charge to obtain the charge of the ion, which is basically -1. Okay, so 3 is the actual structure of the nitrite ion, which is also NO2 negative. Okay, and so this was your answer. And yes, so they're saying C is most likely, and this is true. Okay, so our next question here says, what is the charge of a sulfite? Okay, so if you recall how you form a sulfite, so sulfite is the result of bonding of sulfur to ozone. So ozone is basically 3 oxygens, and so ozone, so let's say, so sulfite, right, this is SO3. Okay, and so as you know, O3, this is ozone. Okay, and so basically we need to draw the Lewis structure of sulfite, and to do this we can say that sulfur is double bonded to one of the oxygen atom, and so this results to a negative charge. So we didn't really put the charges on the chemical formula here yet. To do that, we have to first draw out the structure. And so let's draw out the structure here. Okay, so you have sulfur in the middle, right? Since it has 3 oxygens, it's gonna double bond with one of the oxygens here, and it's gonna form 4 bonds. And so you can probably guess, so we're just gonna put the lone pairs here. 1, 2, 3, 4. Just make the lone pairs. Okay, so this oxygen has 2 lone pairs. This oxygen would have 3 lone pairs. And this oxygen over here would also have 3 lone pairs. Okay, and so as you can see, the oxygen that have 3 lone pairs, they would both have a negative on them. Okay, and so the oxygens that are single bonded would have a negative charge always. And so the result of sulfite, so basically you can say, therefore the charge of a sulfite is, so you can say SO3 to negative. Okay, and this is what they have got here, and this is correct. Okay, 3. Okay, so our next question is, how do you convert millimeters to liters? So this is a conversion question. And so, okay, so the prefix milli is used to denote a factor of 1,000. Okay, so we can say milli, or, yeah, I don't think I spelled it right. Okay, milli is basically, the prefix means, milli means, basically you have to guess it's out of, basically it's out of 1,000. Means, well, yeah, means, so just think about 1,000. Okay, 1,000 millimeters. This would always equal, so when you're talking about like milliliters or any type of liters, you're just gonna convert that to liters. So when you're talking about milli, just remember that it's out of 1,000. So to get so what I mean by that is basically 1 liter is equal to 1,000 milliliters, right? Compared to that. And so you can say that, or you can basically say that 1 milliliters is equal to 1 times 10 to the power negative 3 liters, right? So you just have to divide 1 over 1,000, and so that's how you would get liters, basically. So this is the conversion unit, basically. Okay. Okay, our next question says, what is the strongest chemical bond? Okay, so over here they are saying that covalent bonds are the strongest chemical bonds. And so, okay, so we can also, yes, so covalent bonds, if you recall, are bonds that are formed between non-metals, right? So for example, carbon, nitrogen, oxygen, and all of those. And so basically covalent bonds, they fill in or complete the number of electrons, so they fill their octet, basically making them stable. And so if you have a stable, right, if you have a stable compound, basically this is really hard to break. So the bonds are they're like unbreakable, basically. Okay, and so when you're also thinking about like for example, let's say you have this big carbon chain, okay, like really big carbon chain. These are all carbons, and so carbon chains are very hard to break because they have all like large carbon chains have very high boiling / melting points. Okay, and so this is due to the bond strength between carbons and basically hydrogens and stuff, and so these are very strong, and it requires a lot of energy to break, basically. Okay, and yeah, so this is correct. Yeah, next question says, draw the main Lewis structure of NOF. Draw non-bonding electrons using the dot notation and bonding electrons as a bond. Okay, so we have here nitrogen, oxygen, fluorine, right? And so the number of valence electrons present would be, so let's count the number of valence electrons. Okay, so nitrogen, so valence electrons. Okay, so let's count the valence electrons for nitrogen. And nitrogen, as you know, has 5 valence electrons. Oxygen has 6. Fluorine has 7, right? And if you total that up, you have 18 valence electrons. So total valence electrons. Okay, and so let's draw out the Lewis structure in this case for this compound. Okay, so keep in mind what the elements could form, like which elements can form double bonds, triple bonds, and single bonds. So in this case, nitrogen would form a double bond with oxygen and a single bond with fluorine. Okay, since fluorine has 7 valence electrons, it only really needs 1 electron, not 2, so it only could form 1 single bond. And so you have 6 valence electrons left. You have 2 on the nitrogen and you have 2 on the oxygen here. Okay, so here where the double bond on the oxygen and nitrogen, and the single bond on the nitrogen and the fluorine represents the bonding electrons of the molecule with the dots as lone pairs, basically. Okay, and so the lines represent the bonding. So the line represents the bonding electrons of the molecules. Okay, and so this is the main Lewis structure, and as you can see, it has no formal charge, it's neutral. Okay, and so this is correct. Okay, our next question says, what is the molar mass of oxygen? Okay, and so let's say to derive the molar mass of any element or compound, if it's a compound, you have to first break those down into their individual elements. And in this case, we're talking about just one element here, it's oxygen. So molar mass of oxygen. Right, this is required. And so to figure out the molar mass, we can say, so we can say we know, this is a known fact, that molar mass is equal to the number. So what I mean by the number here is that, okay, to the number of the atomic mass of that element. What I mean by the number is that molar mass, but so we can say molar mass and atomic mass have different units. So what I mean by the same number is just the numbers the same, it's just the units are different, have different units. Okay, and so in this case, let's first compare, so we can correlate with the atomic mass. And so let's say the atomic mass of oxygen, right, this is equal, so your atomic mass is equal to the number of protons plus the number of neutrons, right? You can look this up in your periodic table. And so I have a periodic table right here, and we can see that, okay, so the molar mass is given here, 16, but in order to calculate the atomic mass, so the atomic mass is also given, which is also the molar mass, we can say that the number of protons here is 8, right? And so that's the number of electrons also. And so you can say it's 8 plus 8, which is 16. So your number of neutrons is, in most cases, it's the same as the number of protons. And so the atomic mass is 16 AMU. So we can therefore say the molar mass of, so just go back to the thing. The molar mass of one oxygen atom, right? We're talking about one atom, is 16 grams per mole. So the units for molar mass is grams per mole. Okay. And yeah, 15.9997 is basically the same thing as 16. So we just rounded it, and the solution is correct. Okay. And so our next question says, how is pH determined given the molarity? Okay, so pH, right, it's a scale that determines how acidic or basic a solution is, in simple term. Okay, so an aqueous solution is. So while molarity, or the concentration, is equivalent to the number of moles per liter of per moles of a solute per liter of the solution. And so molarity, and so you can see that pH has no units. Molarity, so yeah, it's basically is the concentration. So you can say molarity is the concentration. Is equivalent, which is, sorry, so I'll just write which is, right, equivalent to the number, of moles per liter solution of the solution. Okay, moles of solute is a solute per solution. Okay, so basically it's the ratio between the moles of the solute by the volume of the solution. Okay, and so basically the units for molarity, so units for molarity, as you can probably guess by now, is moles per liter. Okay, which is equal to which is also called concentration, basically. And so to understand how the pH level is determined given the molarity, let's use an example. Okay, so let's say we have an example right here. So let's say, for example, right, for example, we have nitric acid, okay, which is HNO3 and O3. This has a molarity of 0.0015. Okay, molarity. And so basically when it reacts with water, it will completely dissociate into hydronium and nitrate ions. Okay, and so we can have a chemical, let's say it reacts with H2O. Okay, and so let's have a chemical formula here. Okay, and so we have here HNO3 plus H2O, right? This would give us our hydronium ion, which is H3O, plus our nitrate ions, NO3 negative, right? And so assuming we have 1 liter of the solution, so let's say here we have given volume is equal to 1 liters. Okay, assume that, so basically we can say that the molarity is basically 0.0015 moles per 1 liter, right? We can basically say that this is the molarity of the solution. And so because nitric acid is a strong acid, okay, let's say nitric acid. Acid is a very strong acid, so it would completely dissociate. It would dissociate completely into H3 hydronium ions. So completely dissociates to H3O plus ions. Okay, and so therefore whatever the initial concentration of the nitric acid is, that would be the concentration of H3O plus. So we are basically saying the nitric acid becomes H3O ions basically. So we can say we can basically say therefore concentration, so therefore concentration of so I'm just writing CONCS, concentration of nitric acid, NO3, is the concentration of your hydronium ions. Okay, and so basically once you know the concentration of your hydronium ions, the pH of the solution may be calculated with the formula. So you can calculate the pH now. So let's say, so you calculate pH by basically you take the negative log of your hydronium ion, the concentration of your hydronium ion. Okay, so substituting the value, right, of your initial nitric acid's concentration, which was 0.0015 moles per liter, basically it's basically gonna be the same thing. So negative log 0.0015 molarity. Okay, and so when you put this in your calculator, you would get a pH approximately 2.82, right? And so you can basically see, sorry, I'll just write this here, that so you're basically getting your hydronium ions from your nitric acid, and so you can say therefore, you know, as your closing statement, you can basically say that nitric acid is a very strong acid with a pH of 2.82, right? This is very low, and so you can see it's very, very acidic. And yes, okay, yes, so 2.82, and so the solution compact. Okay. Okay, so our next question here is, why is magnesium chloride named magnesium chloride and not magnesium dichloride? Okay, that's a very good question. And so because of that, okay, so you have magnesium chloride, right? And this is made out of magnesium, this is made out of chlorine. And so chlorine, which has a negative charge, and this has a positive. And so the way it gets its so the way you make this formula, right, chemical formula, just crisscross the charges, and that's how you get MgCl2, right? And so why it's not called dichloride, magnesium dichloride? Okay, you only use like the prefixes, so basically only use prefixes when dealing with basically covalent bonds, right? When you have non-metal and non-metal, right? And from here, how you can distinguish why magnesium chloride. So basically you can say here magnesium chloride is an ionic compound. Okay, and to figure this out, you can basically see the charge of magnesium, which is +2, and it belongs to your group 2, which is over here, right? So this is part of the metals, and your chlorine, which is right here, group 17, and so this is basically your halogens, right? And so this is a non-metal basically, and so your ionic compounds, you make your ionic compounds from your non-metals, from your metals and non-metals, and so you're only using prefixes when you're dealing with only covalent bonds. Okay, and so ionic bonds, ionic compounds don't have prefixes. Okay, and yeah, this is what they're saying. Metal, then writing the name of the number. Yes, so this is correct. Okay. Okay. 9. Okay. So our next question here says, select the properties of an SN2 reaction mechanism. Okay, so we're dealing with organic chemistry kind of here, and this is basically a reaction where you produce different products. What I mean by that more specifically is different stereoisomers. Okay, and so we can say so the question says what are the properties of an SN2 reaction. Okay, and so we can, so an SN2 reaction is a stereospecific reaction, so that is different stereoisomers react to give different stereoisomers of the product. Okay, so you can say SN2 is stereospecific. Okay, so just write this again. SN2 is stereospecific. Okay, and so basically we'll give different stereoisomers of the products. So it is also a bimolecular at the rate determining step. Okay, so bimolecular at rate determining step. Okay, so when you have a bimolecular reaction, basically that's the rate determining step. and so in which the overall rate depends on a step in which there is a collision between two separate molecules. Okay, so rate depends on a collision basically on a collision between two separate molecules. Okay, and so what we're dealing with here in our nucleophile and the electrophiles, right? So electrophiles, right? Basically, right? And so the mechanism has a rate of reaction which depends also on the concentration of the first two order reactants. And so the mechanism, you can say, so this has the mechanism has a rate of reaction which depends on basically the two first order reactants, right? So what we mean by okay, so that's right, depends on the two first order reactants, right? And so basically your second order reaction is governed by the steric effects. Okay, so we can say that the second order, right? Second order reactions is basically it is influenced by steric effects. Okay, so these are the properties, majority of the properties of an SN2 reaction. And so you can say that, so in this, and so the given options here, A is stereospecific, where there's an inversion of the conversion of the reaction site, right? So it's inverted, so it's basically the opposite configuration. So A is one of them, so therefore, just gonna write first thing out, therefore A, okay. So let's see B, not stereospecific, this is wrong, it is stereospecific. Bimolecular at rate determining step, so yes, it is. It's not unimolecular. Second order rates are governed by steric effects. And F, rate is governed by the stability of the carbocation that is formed. No, it's E, so second order rates are governed by steric effects. Okay, so the answer is A, C, and E. Okay, and so yes, so our answer, so this is right. Correct. Okay, our next question here says, how do you write the balanced equation for the combustion of propane? Okay, so when we're dealing with combustion reactions, we're basically producing carbon dioxide and water as our products, basically. And so It says to write the balanced equation for the combustion of propane. Okay, so propane, right? So the chemical formula for propane, when you have, basically prop means you have 3 carbons, right? And to determine how many hydrogens you have, there's basically a formula where, let's write out the formula first. So Cn and H is 2n plus 2, right? When it's only single bonds, right? We're dealing with propane, not propene or ine. And so in this case, we can use this formula, and prop means you have 3 carbons. And to find the number of hydrogens, you just do 3 times 2, which is 6, plus 2 is 8. So this is your chemical formula for propane. And now we are gonna write out the balanced equation for the combustion of propane. Okay, so the balanced equation of the combustion of propane. Okay, and so we can say this is, basically say this is, so C3H8, right? This is a gas, okay, and this will react with oxygen, okay, and this would produce carbon dioxide and water. Okay, so you have carbon dioxide gas and you have water. Okay, and so now we just have to balance the equation right here. Okay, you have, basically you have 8 hydrogens here, right, in your reactants, and so you need 4 more hydrogens for to balance the equation for in the product side. And so that makes you have 6, basically have 6 oxygens, right? And so we can basically say that we have six oxygens, and so you probably would guess you need, or no, let's do carbon first. Okay, we have 3 carbons in our reactants, and we only have 1 carbon here, so let's just put 3. Okay, and so that means we have 4 oxygens from your water, and you have 6 oxygens from your carbon dioxide, and we only have 2 oxygens on our reactants, and that means we need 5 to make it 10, right? We have 10 oxygens on our reactants and 10 oxygens on our products, and so this is balanced. Okay, and so what is a combustion reaction? So basically a combustion is a chemical process where liquid or gas hydrocarbons or hydrocarbon reacts with oxygen. Okay, this is basically seen when, you know, pollution, basically it's from your combustion reactions. And so and this gives off heat and produces carbon dioxide and water. So, and produces heat, CO2, and water. Okay? And so basically, right, we have balanced the equation here, and so we also address what a combustion reaction is, what it is basically, and so you have your balanced equation right here. Okay? Oops. So this is not going to be a gas, this would be a liquid. Okay? And so this is how you have, yes, okay. Okay, our next question says, how do you determine the molar mass of helium? Okay, so if you look at our periodic table right here, helium is a noble gas, right? So it's a gas and it's stable, right? Helium is from group 8, right? 8 or 18 you could say. It is a noble gas. Noble gas, very stable. So I'm just giving some background information. Okay, and you can see that on the top right corner here, it has the number of electrons basically, or it's also the number of protons, and so you can say that helium has 2 valence electrons. Okay, and so you can also say that helium so He is also known as helium, right? And so you can also say that it has it also has 2 valence electrons, and, or let's say, which means, oops, which indicates it has 2 protons as well. Okay, and so when we're dealing with molar mass, okay, molar mass, we can correlate this, so I'm denoting MM as molar mass. We can correlate this with the atomic is related to atomic mass, right? And so we can say, so your atomic mass, let's address atomic mass, is basically the number of protons plus the number of neutrons in the nucleus. And so when we're dealing with, so we're dealing with helium right here, and so we can say that the number of protons, as we saw here, is 2. And your number of neutrons is basically, in most cases, it's the same number of protons. And so you can say 2 plus 2 for helium. Okay? And so we basically have 4 AMU. Okay? We can also say, so like, therefore, the molar mass of helium, which is also He, is 4 or you can say 4.00 basically. 4.00 grams per mole. Okay, and you can see this right here. It's also given in the periodic table right here. So this is your atomic mass and the same thing as your molar mass. Okay, and this is one atom of helium basically. Okay, so the solution. Next question says, what is the oxidation number of nitrogen and NH3? So NH3, so basically NH3, right? Oxidation number for N. So, okay, so there are several ways or rules in assigning oxidation numbers, but we don't really, so there aren't really any rules for nitrogen, but there are rules for hydrogens. So since this is a covalent, so I'll just say NH3, I'll just address NH3, it's ammonia, right? So let's address, so hydrogen, right, it has a charge of +1, so that is its oxidation number or oxidation state of +1. So basically we can say here, right, NH3. So we can say that since one hydrogen atom has a oxygen, so we can say here, okay, so one hydrogen atom has an oxidation number of +1, okay? And so we can say, since we have 3 in this case, okay, it would be, so 3 hydrogens would equal to +3, right, as their oxidation number. So we can basically say +3 here. And so when to get the oxidation number for nitrogen, we must consider that the sum of the oxidation numbers must be 0. So it has to equal to 0 because this is a neutral compound. And so basically to make this neutral, right, so it's now, since we didn't put any charge on nitrogen yet, the compound is at a charge of +3. And to basically balance this or make this 0, we have to have a basically, so nitrogen has to be a number where it can balance out the 3 and become 0. So you can have an equation here, standard equation. Let's say X is the oxidation number for nitrogen, and you have basically you have X, right, and you have plus, let's say 3 and 3 equals 0 basically. Or let's say, okay, oops, so let's say you have X plus 3, right? 3 is probably your hydrogen, and X is the number, the oxidation number for nitrogen. Let's say, sorry, N plus 3, right, is equal to 0. We need to get 0. So you can say N is equal to -3, right? And so basically, the oxidation number for nitrogen is -3. So, and this is what makes it a neutral compound. So you can say, therefore, the oxidation number for nitrogen in NH3 is -3, okay? And so yeah, this is what they have got. So the solution. And so that brings us to the end of our session. If you really like this Q&A, please like, share, and subscribe to OneClass. And if you have personal questions, you can follow the links down below and follow the links and ask your questions. And other than that, I'm Shanjida, and I just went over some commonly asked chemistry questions both at the university and high school levels. And other than that,